Om Shri Sai Ram. My humble salutations to my beloved Bhagwan, respected elders and my dear students. Hearty welcome to three-dimensional solid geometry class. Today we are going to learn about unit number 5, cones, notations and finding the vertex of the cone. Notations. Let S represents the second degree general equation in XYZ. The following notations are used in this particular chapter. S is given by ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus 2ux plus 2vy plus 2wz plus d. And E is given by E of xyz, that is nothing but ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy. Capital U is denoted by ax plus hy plus gz plus u. Capital V is denoted by hx plus by plus fz plus v. And W is denoted by gx plus fy plus cz plus w. And capital D is given by ux plus vy plus wz plus d. U1 is given by ax1 plus hy1 plus gz1 plus u. And capital V1 is denoted by hx1 plus by1 plus fz1 plus wv. And w1 is given by gx1 plus fy1 plus cz1 plus w. And capital D1 is given by ux1 plus by1 plus wz1 plus d. Then S1 is denoted as AXX1 plus BY1 plus CZZ1 plus F times YZ1 plus Y1Z plus G times ZX1 plus Z1X. And we have H times HX1 plus X1Y and U times X plus X1 plus V times Y plus Y1 plus W times Z plus Z1 plus D. That can be rearranged and it can be written as ax1 plus hy1 plus gz1 plus u times x. Similarly, hx1 plus by1 plus fz1 plus v times y, gx1 plus fy1 plus cz1 plus w times z, and plus ux1 plus vy1 plus wz1 plus d. That is nothing but u1x plus v1y plus w1z plus d1. And hence we can also write this as follows. S11 is given by u1x1 plus v1y1 plus w1z1 plus d1. So this can be remembered using the following lesson, following theorem. Now if x1, y1, z1 is the vertex of the cone S is equal to 0, then the condition is u1 equal to v1 equal to w1 equal to d1 equal to 0. Let the equation to the cone be S is given by ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus 2ux plus 2vy plus 2wz plus d equal to 0. And given vertex of the cone P is nothing but x1, y1, z1. Now shifting the origin to the point capital P, the new equation of the cone referred to the vertex P as the new origin is a times x plus x1 whole square plus b times y plus y1 whole square plus c times z plus z1 whole square plus 2f times y plus y1 into z plus z1 plus 2g times x plus x1 into z plus z1 plus 2h times x plus x1 into y plus y1 plus 2u times x plus x1 plus 2v times y plus y1 plus 2w times z plus z1 plus d equal to 0. Now that can also be written as ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus 2x times ax1 plus hy1 plus gz1 plus u and 2y times hx1 plus by1 plus fz1 plus v and 2z times gx1 plus fy1 plus cz1 plus w plus ax1 square plus by1 square plus cz1 square plus 2f y1 z1 2g z1 x1 2h x1 y1 and 2u x1 2v y1 2w z1 plus d equal to 0. Now e of xyz plus 2u1x plus 2v1y plus 2w1z plus s11 equal to 0. This must be a homogeneous equation that implies u1 equal to 0, v1 equal to 0, w1 equal to 0 and s11 equal to 0. But S11 can be written as u1 x1 plus v1 y1 plus w1 z1 plus d1 equal to 0. That implies d1 equal to 0. Therefore, u1 equal to v1 equal to w1 equal to d1 equal to 0. Now, corollary of this, if the equation S is equal to 0 represents a cone, then the condition is, we have to remember like this, A, B, C, D, and then U, V, W, U, V, W, here also U, V, W. The rest of the F, G, H, and we can write F, G, H, we can write like this. So we can consider that is the we can write this ABC, this diagram. Okay. So this one in the diagonal you can write down ABCD, and further we can write UVW as usual here like this. And then here also UVW you write down like this. Then we are left with only that is three terms downwards and three terms upward. So this can be written as FGH like this. And similarly, we can write, we have to remember this arrow marks, then we can easily complete this. So this way, we can clearly write down this expression ABC, UVW, FGH, FGH. I think now you can remember. Okay. Now, eliminating this is usually x1, y1, z1 in the equations. That is u1 equal, we consider u1 and v1 equal to 0. That already we have got the condition for the cone to have the vertex of x1, y1, z1. So eliminating x1, y1, z1 from these four equations, we get this particular determinant equal to 0. This is a required condition for the equation S is equal to 0. That represents a cone. I hope this is clear. Okay, we'll go to the next one. Right. Now, corollary 2. The vertex x1, y1, z1 satisfies these equations, namely capital U equal to ax plus hy plus bz plus u equal to 0, and capital B, another equation that is hx plus by plus fz plus v equal to 0, and w is nothing but gx plus fy plus cz plus w equal to 0, and capital D equal to ux plus by plus wz plus d equal to 0. Thus, the vertex is obtained by solving any three of the above four equations. Now consider the homogeneous polynomial S of x, y, z, t, that is nothing but ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus 2uxt, 2vyt, 2wzt plus dt square. Now consider the partial derivative of this equation dou s by dou x as 2 times of ax plus hy plus gz plus ut, and dou s by dou y is given by 2 times of hx plus by plus fz plus bt, and dou s by dou z is given by 2 times of gx plus fy plus cz plus wt, and dou s by dou t is given by 2 times of ux plus by plus wz plus dt. Now equating these four equal partial derivatives to 0 and putting the value t equal to 1, we get capital U equal to capital B equal to capital W equal to capital D equal to 0. Now consider this particular equation. Now, if ax square plus by square plus cz square plus 2ux plus 2vy plus 2wz plus d is equal to 0 represents a cone, that prove that u square by a plus v square by b plus w square by c equal to d. So what is given here? That is, we are provided with actually we are provided with this particular cone equation, and we have to show that we are provided with an equation and we have to show that that represents a cone if this condition is going to be fulfilled. That is what we have to do. So what is given? An equation is given and you are asked to show that it represents a cone. Okay. Now in order to prove this particular, what we are going to do is that now x1, y1, z1 be the vertex of the given cone. Now, definitely, if you consider the cone, automatically what is going to happen? Now, um, let us say the vertex of the cone as x1, y1, z1. So we are having x1 and y1 and z1 as the vertex. Then what are the conditions? u1 equal to 0. This is okay. Now what we are having, that is, we are comparing the given equation with the original equation. What is the original equation actually? This is the given equation, no doubt about it. But when you consider um, the original equation, what is the original equation of the given equation? So ax square plus, we are having, what is the original equation of the cone? That is ax square plus by square, by square, and then we are having that is by square, and we are having that is nothing but cz square. C z square we are having, and then we are having that is 2f yz, 2f yz, 2f yz, 2g zx, 2f yz, and then we are having that is 2g zx, 2g zx, and then what else we are having? 2g zx, and then we are having 2hxy, that is second degree equation in xyz, 2hxy plus 2ux and 2ux, and then 2vy. So this is 2vy, 2vy, and then 2wz, 2vy plus 2wz, 2wz plus d equal to, plus d equal to, this is our equation. But what is the given equation? The given equation is here. Now what is happening here? So in this particular case, f equal to 0, and we are having f is 0, and then we are having g is 0. There is no zx term, so g is 0. And then what about that? There is no h term. Xy term is also not there. So this is. Now what is u1 actually? So what is u1 here? Actually we are having, what is u1? U1 is nothing but, so the first row. So do you remember what is the first row? ax1, ax1, and then we are having ax1 plus hy1. Okay, hy1, ax1 plus hy1. And then what else we are having? ax1 plus hy1. What else? ax1 plus hy1, and then gz1 plus u. gz1, gz1 plus u we are having equal to 0. But h is 0 here, and g is also 0. H is 0, g is also 0. So what do you get? That is nothing but a x1. So I need not write down because already it is there. So we get a x1 plus u equal to 0. In other words, x1 becomes now u by a. Similarly, we can easily see that is y1 equal to v1. When you consider v1, other condition, 4 conditions are there. u1 is 0, v1 is 0, this. So what is y1? y1 is equal to, what do you get? Minus v by v we get. And similarly, we get that is the z1 is given by, that is nothing but minus w by c. Therefore, and for the d1 is 0. What is d1? ux1 plus vy1 plus wz1 plus d equal to 0. Now replace x1 by minus u by a, and replace y1 by minus v by b, and replace z1 by minus w by c. Then we get this particular equation, minus u square by a minus v square by b minus WD squared by C plus D equal to 0. In that way, so we get that is equal to 0. Next, we will go to the next one. Now find the equation of the cone 7x square plus 2y square plus 2z square minus 10zx plus 10xy plus 26x minus 2y plus 2z minus 17 is equal to 0. Sorry, second one. So when you consider this automatically, what is going to happen? So find the vertex of the cone 7x square plus 2y square plus 2z square. So I hope that is clear. I'm going to close this. I will go to the second one. That is, find the vertex of the cone 7x square plus 7y square plus 2z square minus 10zx plus 10xy plus 26x. Now find the vertex of the cone 7x square plus 2y square plus 2z square minus 10zx plus 10xy plus 26x minus 2y plus 2z minus 17 is equal to 0. Now consider the homogeneous equation. What is a homogeneous equation? S of x, y, z, t. That is nothing but this equation. We have to homogenize. So for the beginning terms, that is x square, y square, z square, and minus 10zx minus 10xy plus 26x. So there is no need till here. No need of multiplying with t or t square. When it comes to 26xt, in order to make it as power 2, we consider 26xt minus 2y(t) plus 2zt minus 17t square equal to 0. Now differentiating partially with respect to x, we get 14x minus 10z plus 10y plus 26t. That is nothing but 14x plus 10y minus 10z plus 26 by putting t equal to 1. And dou s by dou y becomes, that is nothing but 4y plus 10x minus 2t, that is nothing but 10x plus 4y minus 2. And dou s by dou z is given by 4z minus 10x plus 2t, that is nothing but minus 10x plus 4z plus 2. Dou s by dou t is given by 26x minus 2y plus 2z minus 34t, that is nothing but 26x minus 2y plus 2z minus 34. Now, coordinates of the vertex satisfying the above equations are these four equations, namely 14x, 10y minus 10z plus 26 equal to 0, minus 10x plus 4z plus 2 equal to 0. Similarly, we are having this. Now, solving 1, 2, 3, we can see that x equal to 1, y equal to minus 2, z equal to 2. And then substituting this x, y, z value in this equation, we get the equation gets satisfied. Hence, the vertex of the cone is nothing but 1 minus 2, 2. Now, show that the equation represents a cone whose vertex is same model. So, consider the equation, homogenize the equation. First step, homogenize the equation. Next step, consider the partial derivative of the equation with respect to x, y, z, t, and then put t equal to 1, and that's all. These are the 4 steps. So we will get the particular vertex by solving this equation. We can see that vertex. Now, E of x, y, z equal to 0 will have 3 mutually perpendicular generators implies and implied by a plus b plus c equal to 0. Given equation of the cone E of x, y, z equal to x square plus by square plus cz square plus 2f yz plus 2g zx plus 2h xy equal to 0. So one of the generators, let us say that if the cone is going to have 3 mutually perpendicular generators. So we are going to have a cone with the 3 mutually perpendicular generators. Imagine okay, so like this it is there. Now it is admitting 3 mutually perpendicular generators. Now I'm going to consider the line, one of the generator, one generator as x by p, y by q, z by r with the generator of the cone. Therefore, E of the dias of the generator should satisfy the equation of the cone. Therefore, we get AP square plus BQ square plus CR square plus 2F QR 2GRP 2HPQ equal to 0. Now we have to consider a plane, okay, and that plane, how it is going to be? It should be perpendicular to. It should be perpendicular to. It should be perpendicular to the given. Okay, so consider this. So consider the plane. So this line, this generator is perpendicular to this particular. So I'm going to consider this. So what are the DRs of this? That is P, Q, is nothing but P, Q, R. So what is the plane equation? There is nothing but the plane equation is nothing but Px plus Qy plus Rj. This is the plane equation. And because the point is there on the cone, so we get the condition because it is a generator. The DRs of the generator should satisfy the equation of the cone. So we get instead of xyz, replace xyz by pqr. This one. This is how we get. So we are getting, so now the condition is that further where what are the, so we are going to find out what is this particular plane consisting of these two generators. Actually, to be frank, we should consider actually. So this is the plane letters. So what do you get here? That is so these other two purple lines that I have drawn, that will be on the plane. So what are the DRs of one of this line? I'm going to consider this as, okay, this is one generator. This is one generator. And I can say another generator as, this is another generator. So how are these two? B one is good. Okay. And the original which I have taken that. So how are these two? Then I will consider the DRs of this particular line, the DRs of that particular line as LMM. Then what is this yellow generator? So how many generators are there? Three generators. What are the colors? One is purple, the other one is yellow color, other one is green. So PQR and LMN, yes, they are perpendicular to each other. So we get PL plus QM plus RN equal to 0. This is what we get this condition because they are perpendicular. Next, again, we are having another one, that is this generator is on the cone. So we get this condition, that is AL square plus BM square plus CM square, okay, plus 2FMN 2GNL, and then this is nothing but 2HLM equal to 0. Okay, I think that is clear. Now eliminating n between 4 and 5. So we get from this, we can easily see that what is n from this equation, what is n? N is nothing but minus of, open the bracket, PL plus QM minus of PL plus QM minus of PL plus QM minus of PL plus QM divided by 2 divided by R we get. Okay. So we can write A in AL square plus BM square plus C into, we are going to incorporate this, and wherever n is there, replace n by this particular number, then we get this particular equation. Now, on further simplification, dividing with the m square, we get l square by m square into something. Similarly, plus 2l by m and without l by m. This represents a quadratic equation in L by M. I hope that is clear. Okay, now on further simplification, what do you get? Now, so we get two roots. So let us say L1, M1, N1 and L2, M2, N2, B2, DRs of the normal to the, DRs of these two generators. Now, how are we getting? We are getting that by the intersection of this. So, the roots would be L1 by N1, L2 by M2, So we get L1, L2 by M1, M2 is nothing but constant by square term coefficient. The first constant term is BR square plus CQ square minus 2FQR divided by R square plus CQ square minus 2GR2. So that implies L1, L2 by BR square plus CQ square minus 2FQR, that is equal to M1, M2 by AR square plus CQ square minus 2GR2. That is nothing but M1, M2 divided by AQ square by cyclic order. By symmetry we can write it. But what is finally L1, L2 plus M1, M2 plus M1, M2? That is nothing but K times L1, L2 is given by AR square plus CP square plus 2GR3. So now we substitute these values and we can rearrange. And finally, we can write this as K times of A plus B plus C into P square plus Q square plus R square. Therefore, the two generators of intersection of the plane 3 with the cone are at RT angles. So L1, L2 plus M1, M2 plus M1, M2 equal to 0. That is implies and implied by A plus B plus C equal to 0. Since the plane 3 is perpendicular to generator 1, the two generators of intersection of the plane 3 with the cone are perpendicular to generator 1. Thus, the three equations they satisfy that test. Just coming now. So what is going to happen now? We are having A plus B plus C equal to 0. That is the condition that we are having. So E of x, y, z is becomes ax square plus by square plus cz square plus 2fy plus 2gzx plus 2hx equal to 0. That becomes the equation of the cone where f of x, y, z equal to 0 has three mutually perpendicular generators. Now show that the two lines of intersection of the plane ax plus by plus cz equal to 0 with the cone yz plus zx plus xy equal to 0 will be perpendicular if 1 by a plus 1 by b plus 1 by c equal to 0. Now the equation of the cone is yz plus zx plus xy equal to 0. That is a given equation of the cone. And clearly we are having in this particular equation the coefficient of x square plus coefficient of y square plus coefficient of x square equal to 0. Therefore, the cone contains sets of three mutually perpendicular generators. Now, what is the given plane? Ax plus by plus cz is equal to 0. This cuts this given cone. So, the perpendicular generators. So, what is given here? So, we are having a plane, namely, the given plane is that is we are having that is equal to, let us say this is a plane that is given by ax plus by plus cz equal to 0. So obviously, what is the generator of this particular code? The generator of this particular code will be so x by a, y by b, z by c. X by a, and then equal to y by b, equal to z by c, equal to z by c. X by a plus y by x by a equal to y by b equal to z by c. Now, because this is also a generator, so how is that particular cone? I am going to consider two more generators. Let us say this is one generator. The other one I am going to consider that is another one. This is another generator. So, like this. Now we have to consider a cone containing these generators. That means we are going to have a cone. So this is the cone, let us say. Then this cone is admitting these three generators. They will be in different directions. One is this purple color, and another one as consider this as another one. This is let us say the pink one, the yellow one. Okay. Yeah. That becomes. So in this way, now anyway, the DRs of the cone ABC satisfy this equation. Therefore, BC plus CA plus AB equal to 0. Dividing throughout the equation by ABC, we get 1 by A plus 1 by B plus 1 by C equal to 0. Okay, that's how it is. So, if the line x equal to y by 2 equal to z represents one of the three mutually perpendicular generators of the cone, 11yz plus 16zx minus 11 14xy equal to 0, then find the equation of the other two. So, in simple terms, the given equation is so the given equation of the cone is 11yz plus 16x minus 14xy equal to 0. The plane through the vertex of this cone and perpendicular to the generator is x by 1 equal to y by 2 equal to z by 1. Now this is nothing but now is x plus 2y just like before. So we are given with the we are given with a so we are going to consider the plane. We are going to consider this particular plane. And how is this plane? This plane is perpendicular to the given line. So what is the dx of this line? 1, 2, 1. So automatically, what is the equation of the cone? The equation of the cone is x plus 2y plus z equal to 0. The other two generators perpendicular to are the lines of intersection of okay 11yz and 6zx minus 14xy equal to 0. X plus 2y plus z equal to 0. Let element be the direction ratios of the one of the common lines. Then we are having 11 mm plus 6 ml minus 14 mm equal to 0 and L plus 2m plus m equal to 0. Therefore, n becomes equal to minus L minus 2m. So that becomes 6L square. Now, using this value in the cone equation, we will get the two values like this 2L plus 11m equal to 0 and 3L plus 2m equal to 0. Now, solving these two equations, we get this. The other two perpendicular generators are x by 11 minus 11 equal to y by 2 equal to z by 7 and x by 2 equal to y by minus 3 equal to z by 2. So that is how we get this. Show that the right circular cone has sets of three mutually perpendicular generators. Then its semi-vertical angle must be tan inverse root 2. Let the origin be the vertex, element be the direction presence of the axis of the cone, and alpha be its semi-vertical. Now, what is the equation of the right circular cone? We know that the equation of the right circular cone. What is the equation? Suppose we are having x1 y1 z1, and the axis of the cone is the tiers of the axis of the cone are L and N and N. And if alpha is the semi-vertical angle, then the equation of the right circular cone is given by L into x minus x1, L into x minus x1 plus m into y minus y1, y minus y1 plus n into z minus z1 square, that is equal to, that is nothing but L square plus m square plus n square, L square plus m square plus n square, L square plus m square plus n square into, this is into there x minus x1, x minus x1 square plus y minus y1 square, y minus y square plus z minus z1 whole square. Z minus z1 whole square into, we get, that is equal to cos square of cos square of, so the coefficient of x square. Now here x1 y1 z1 is, in this particular example, it is origin. So if you consider that as origin, then this becomes this equation, x plus n by plus n whole square equal to x square plus m square plus n square into x square plus y square plus z square into cos square alpha. Since the cone has three mutually perpendicular generators, we have coefficient of x square plus coefficient of y square plus coefficient of z square equal to 0. Therefore, coefficient of x square is nothing but L square minus of L square plus m square plus n square into cos square alpha. Similarly, coefficient of y square is nothing but m square minus of L square plus m square plus n square into cos square alpha. Coefficient of z square is given by m square minus of L square plus m square plus n square into cos square alpha. Adding, we have, that is L square plus m square plus n square minus 3 into L square plus m square plus n square into cos square alpha equal to 0. That becomes 1 minus 3 cos square alpha equal to 0. Therefore, 3 cos square alpha equal to 1. Therefore, cos square alpha equal to 1 by 3. Therefore, secant square alpha equal to 3. That is how we get. Okay. So, in this way, you can see that secant square alpha can become as 1 plus tan square alpha. So, tan square alpha equal to 3 minus 1, that becomes 2. Therefore, tan alpha equal to square root of 2. Therefore, alpha equal to tan inverse. So, that is how we I show that the cone whose vertex is origin, which passes through the curve at the intersection of the surface and the plane at the distance d, when the origin has three mutually perpendicular generators. So, what is the plane? It is at a distance of d, therefore Lx plus My plus Mz equal to 0. The element at the actual disease of the normal to the plane. Homogeneousing this equation, 2x square minus y square plus root y square equal to 3b square into 1 square. That is nothing but lx plus my plus nz by b whole square. Now coefficient of x square plus coefficient of y square plus coefficient of z square equal to 2 minus 3l square. Okay. So on further simplification, we can happily see that this becomes 0. Therefore, that's the cone in 3 mutually perpendicular generators. If the plane cuts the cone in perpendicular lines, then find C. So the plane is cutting the cone. So the plane as well as the cone, they are passing through the 0, 0, 0. And further, this plane is cutting. So contains the sets of 3 mutually perpendicular generators. 2x minus y plus cz equal to 0. That's one perpendicular lines. Therefore, the normal to the plane lies on it. So what is the dx of the normal? 2 minus 1 c. So 2 minus 1 c must satisfy the condition of the cone. So that implies y is minus 1 into c. So c into 2 plus 2 into minus 1 into 0. So c equal to. Find the locus of the point from which 3 mutually perpendicular lines can be drawn to intersect the central point. X square plus dy square equal to 1. At the point PB, x1 y1 z1, any line 2P is given by x minus x1 by L is equal to y minus y1 that is equal to k. Therefore, x1 plus Lk, y1 plus Mk, z1 plus Mk is equal to z2. If this point lies on this particular point, then we have a into x1 plus Lk also plus b into y1 plus Mk square equal to 1 and z1 plus Mk equal to 0. Therefore, we have a into x1 minus lz1 by n whole square plus b into y1 minus lz1 by n whole square equal to 1. So that implies a into nx1 minus lz1 whole square plus b into ny1 minus lz1 whole square equal to n square. Therefore, using 2 in this equation, we get the required equation. Eliminating L. What is L? X minus x1. What is M? Z minus z1. What is y? Yeah, what is m? Y minus y1. Finally, we can see that the coefficient of x square plus coefficient of y square plus coefficient of z square equal to 0. So this is the required.